Hello, everybody, and welcome to our new webinar today. We're going to talk about fully automated OpenStack Cloud orchestration with OpenQRM Enterprise. Great topic. I'm going to quickly take you through the agenda and then hand over again to our founder and senior technical advisor, Matt, who's with me again today.
I would like to start a quick few words about OpenQRM Enterprise and what we are doing and what's our goal and what you can do with it, how it is managing different other technologies and automate them. This goes quickly through management, monitoring, automation, deployment, self-service. There's a self-service portal. It means every kind of action in OpenQRM you can make cloud service. We have built-in high availability for all provisioned and managed systems in OpenQRM, and of course a hybrid cloud integration where we created interfaces to OpenStack, Amazon, EC2, Azure, and other public and private cloud vendors to integrate their resource model into OpenQRM and to be able to fully automate. There's a large variety of different plugins available for all different purposes of data center management, system administration, IT service automation, and of course cloud service based on infrastructure as a service. So this is the general architecture of OpenQRM Enterprise. We see on the right side, for example, is the resource abstraction layer, where each virtualization technologies and also physical systems are abstracted in a generic way. So OpenQRM server itself works on a generic layer, on this abstraction layer, where plugins interface with different technologies and bring the specific customization for each actions into OpenQRM. The same we have on the left side. This is the storage abstraction layer. So any type of storage, if it's distributed, clustered storage, or any type of NAS or SAN-based storage can be easily used and attached to OpenQRM via the storage abstraction layer and then fully transparently managed and automated by OpenQRM. We, of course, made interfaces to OpenStack to automate the provisioning for OpenStack itself and also the virtual machine provisioning later for as a self-service. So basically, we can put OpenQRM on top of OpenStack using OpenStack as a resource provider, provide different added values on top of that, like easy IP management and automatic monitoring, different services which are useful for the end user then. OpenStack is a completely distributed system. It consists of different web services which are stacked together. Here, a general overview about the architecture of OpenStack, how you can organize it, put it together. So there are different components which are orchestrated in a distributed manner in your infrastructure. It all ends up in a dashboard where you can have the self-service provision your virtual machines. This can get, of course, much more complex when we look at, for example, high availability for OpenStack infrastructure. Each of those objects must be made high available itself to have the full environment high available. I will show you now how we can orchestrate OpenQRM infrastructure, meaning the OpenStack backend environment for your private cloud with OpenQRM and keep it high available on infrastructure level in a very easy manner. The second, where we have a live demo, is how we interface with OpenQRM Cloud with OpenStack directly. So to sub-cloud and add values for OpenStack on behalf of OpenQRM Enterprise. In OpenQRM, a fully automatic OpenStack Cloud installation on bare metal or on virtual machines available. This is based on customized Puppet recipe where you can add configuration parameters in the OpenQRM UI, how you would like to have OpenQRM deployed in the infrastructure. This is made on behalf of the application deployment abstraction layer in OpenQRM. So we have different types of configuration management system, such as Puppet and also Ansible. We use this for the automatic OpenStack installation of the infrastructure and also for the OpenQRM Cloud backend as an additional value, additional service on top of OpenStack to be able to cloudify applications so that the end user can select them as a self-service, meaning they can provision virtual machines with several different customized applications attached. This is now in the OpenQRM Cloud. We have also, like, when I come to cloud products, like the application will be just another cloud product. When we say product, there must be also like a kind of charging model behind it, a billing model. we have integrated generic billing system in OpenQRM, which can be easily attached through OpenQRM Enterprise's API to any other billing system which you may have already in your company, or the data can be exported so that they can be reused on different other platforms for billing purposes. We also add values in the monitoring section, so there are also different monitoring options in OpenQRM available, like Nagios or Sabex and CollectD. Monitoring is also something we add on top of OpenStack. The OpenStack systems can be automatically monitored by OpenQRM. This is all well documented. We have several how-tos also for other hybrid cloud deployments like on Amazon or on Azure. If you look on our website, you can find step-by-step guides with lots of screenshots where you will be assisted to the different configuration for different technologies to automate them with OpenQRM. A very important aspect for many of our customers is high availability. We have to see different layers of high availability, like an infrastructure level where the systems must be failing over completely to other hardware or virtual machine hardware. Then we look on application level where services needs to be configured for immediately failover when the system goes down. So both aspects of high availability I will show you today. A screenshot flow for how we provide automatic OpenStack Cloud provisioning in OpenQRM Enterprise in the administrator backend. The second will be live demo where we look at our QA environment and check how OpenQRM can be a benefit for OpenStack if you run it on top of OpenStack. First, high availability in OpenQRM for physical systems and also available on virtual machines is made on a generic architecture. That means it's built in within the OpenQRM model. For physical machines, we have here an example based on a completely image-based deployment for bare metal systems, where through network boot procedure, we directly attach an operating system image either via a SAN or an iSCSI target. Actually, hardware will become less important since the image is remotely attached during boot stage and still available if the hardware burns down or crashes or whatever. So we can easily fail it over to another system, which then happens, of course, fully automatically in OpenQRM. This is, we call an end-to-one failover, which means we can assign a group of servers to be high available on its own on infrastructure level, and they can use a single standby in OpenQRM. It can be even run in power off mode, so OpenQRM will automatically turn on the standby if it's needed. And we also have options for high availability failover, where during the failover, transparent migration is being made from physical machines to virtual machines. This allows you to use a group of servers, have a single standby, and if all of the servers failed, they will be recreated and failing over into virtual machines on the single standby. We're coming now to the OpenStack automatic deployment and HA functionality. In OpenQRM, it's quite easy to bring out an OpenStack environment. We create a new server, name it OpenStack. We select a resource, which will be, in this case, a physical system available in OpenQRM. We select an image which we have prepared, which we have created. In this case, it's an empty iSCSI image, which we attach to this physical system, because on the next step, we will attach an automatic Ubuntu installation to this empty iSCSI image. So during boot up, it will be automatically installed once. Then it's completely ready, and after that we attach the application, for example the server configuration, where we assign different configuration parameters on behalf of the OpenStack installation, which we will configure in the next step. This is the IP configuration, just one more step. So this is the application configuration for this deployment. We just select the OpenStack private cloud application, which comes with the OpenQRM basic installation. This server construct then will, when it's restarted, will reboot the physical machine, attach the empty iSCSI image, populate the empty iSCSI image in the pre-boot stage with a Ubuntu system, which will be immediately booted after that. When it's booting up, the OpenQRM client on the physical system then will start the boot services, which will get Puppet in stage, and Puppet will then install OpenStack according to the configuration we have made at the server automatically on the system. So after starting, basically your OpenStack cluster will be available automatically. Next step, start the server. This is a few minutes later when it's got active. When it's active, it has populated the operating system and then the OpenStack application through Puppet. Next step is enable the automatic high availability for servers in OpenQRM. It's just a single button, enable HA, which brings you to another option where you can configure a high availability timeout for each of your system which you have configured HA mode, in HA mode. This is useful, for example, if you have systems which are staying very long, which are needing very long in the pre-boot section when they are starting up, like in the BIOS section. It's useful to be able to set the HA timeout a bit higher than by default. Next thing is boot up another physical system, which is shown on the bottom here. This is available for OpenQRM as a failover, as a standby system. Since the OpenStack server, which we just created, is marked as high available, it will use this standby system for failover if needed. And boom, now it's needed. We have crashed the OpenStack system. We see now the resource of the OpenStack server is getting in transition state, which means there's something happening. The next will be that the OpenStack server shortly got inactive. It will be restarted immediately after adding the failover resource to it. Next, we see our OpenStack server is completely active and available again. This shows how automatic failover in OpenQRM works. It just picked the free resources, the standby machine, which we booted before, and replaced it in our server object. So it will just bring up the same image as we pre-configured before with OpenStack. And when we see at the resource level, we see the previous OpenStack resource, the physical system, is still in error state. It completely turned off for this example. The OpenStack server now runs on the standby system, which is now activated by OpenQRM for the failover. This makes it very easy to have also distributed OpenStack environment be on a high available level, very easy. Since it's a built-in feature in OpenQRM, just marking it with the HA checkbox. I will now switch over to my web browser and show you how we can use OpenStack as a resource provider for OpenQRM Enterprise, either for system administration backend or for the cloud self-service. Yeah. This is the main dashboard for the OpenQRM Enterprise administration backend. This provides an interface for all different kinds of technologies used by system administrators, helps to automate in a single workflow. I can show you here, this is the plugin manager configured for this demonstration. This is basically a server from our QA environment. There are lots of different technologies which can just be enabled to use them in a seamless and transparent way in OpenQRM. For this demonstration, we have made OpenQRM itself a hybrid cloud host manager, which means it now can interact with different public or private cloud providers, which we configure in the hybrid cloud section then. And as we see, there are also like a few virtual machines already running on our OpenStack backend. This is the hybrid cloud plugin menu where we configure the different authentications to different cloud providers to be seamlessly integrated in OpenQRM as another resource provider, and also for the capability to put OpenQRM Enterprise Cloud on top of Amazon EC2, Azure, or also OpenStack. Here we see one of the user administrators accounts on our OpenStack backend. As the administrator, see and browse all the instances which are currently running there too. Configure OpenStack in a manual way. Use it as a virtual machine provider, basically. Not care about a self-service. The self-service we can put on top of OpenStack, on every resource provider via the OpenQRM Cloud. And now show you the cloud portal. This is the user front end, where end users can log in and get a self-service on any kind of provisioning and deployment which you have configured in OpenQRM Enterprise. A workflow in OpenQRM, any server configuration can be made a cloud product, which is then available in the OpenQRM Enterprise Cloud. So we'll log in here. Okay. We have already something running here. This is the limits overview, where we can see how much access or how much resources we are already using on our OpenQRM Cloud, and how much resources we have still free available for further provisioning. We see 2 instances active. Of course, those limits are configurable in OpenQRM per user, and also there are global limits. As a user, I can see my instances, I can configure them, I can pause them, I can also throw them away when I'm not using it anymore. The general cloud thinking, if I'm not using it, I'm just destroying it. If I want something new, we simply can request systems from the OpenQRM Cloud As the end users say, select the virtual machine type or the hybrid cloud type we want to get for our provisioning. So in this case, it will be hybrid cloud. We also can configure the further details, like how many network cards it should have, if it have second network IP addresses from certain pools. For this, I'm leaving this by default. And we will call this webinar, or webinar system 1. This is the application section. We can also install directly applications on this system, which will be provisioned as a virtual machine on OpenStack. For example, let's make it a web server and a database server. This will be attached to the virtual machine provisioning and being configured on the virtual machine later on OpenStack fully automatically. Let's keep it also high available. For the end user, you see high availability is just a checkbox which enhances or which increases the cost for this virtual machine, which of course you can configure fully transparently in the OpenQRM backend. So let's go. And this allows us to run a modern cloud interface with an intuitive user-friendly administration on top of OpenStack with billing system completely included. So as the end user, I can also see my transactions, which are currently still empty, to see what my systems are, which are the cost for the systems for a number of time. After a few minutes, this will be approved automatically. It's also something you can configure and set up. We have also the option to have a manual approval for the OpenQRM Cloud. In most cases, an automatic approval will be beneficial because you don't want to have any work with that. After a short time, this system will be then also available for me as a user. This is how we can use different kinds of cloud providers and provide access to it in a single management UI for administrators and also for front-end users using it as a self-service for the infrastructure. See, it's currently on provisioning. That means it's switched to busy. It should be available in a few seconds. I can show you also, this is the OpenStack backend, which I'm now accessing with the general OpenStack dashboard. And if we see here, we can see how our 3 systems are available. The latest system is just being started and created right now. So it should be also available and active in our private cloud. And if you don't need any of those systems anymore, we can simply throw them away to free up resources and to decrease costs for the end user. This was the live demonstration. Thanks for watching. Thanks for your time. I hope you enjoyed this webinar. Many thanks and have a nice day.